Everybody, please take your seats. We're starting.
Cheers.
All right, I hope you had a good lunch. I did. This year, Ethan is talking more about Binderoo,
Yes.
but with a bit of a twist.
I'm not giving it away right now. You've got to wait for the talk.
All right, so everybody, Ethan Watson.
Alrighty. Cool. Okay, so I'm back here for my third DConf presentation. Wow, how'd that happen? But yeah, I do have some important stuff today to get through, so let's get started. Squirrels. Yes, squirrels. Squirrels. Okay, I pulled the squirrels, and they are quite important, especially when it comes to an emerging, completely legitimate scientific field of fictogeography. For example, you may have heard that the so-called land of Australia is a fictional place and entirely fabricated. And I can actually prove this because in Australia, they don't have squirrels. This seems like a glaring oversight in the creation of the Australian mythology. I mean, just think about it, right? Europe, squirrels. Africa, Asia, squirrels. North, South America, yeah, they got squirrels. But Australia, no squirrels. Clearly, if such a place were to exist, it would have squirrels, just like absolutely everywhere else in the world. Whoever invented Australia really didn't think things through here. Another place where a lot of fictogeographical research is currently focused on is the fictional country of Finland, which, as you can't really see there, is actually a Japanese fishing colony. And again, the squirrel comes in handy for proving that this is actually a completely made-up place. Because in Finland, they supposedly have a fairly long and dark winter. Lots of snow, really cold, and apparently their winters are so bad that only 15% of squirrels survive their first winter. Have you ever heard of anything so preposterous? Squirrels are much more resilient than that. And, you know, I am something of an expert on the matter here because, you know, I was born in Australia and I've lived in Finland for almost 6 years. So I do have quite an extensive amount of experience here. Yeah? That's valid. That's valid. Fictogeography has nothing to do with D here. You're right, presentation. But you see, here's the thing. I quit my job at Remedy in December last year. I've been on my own time since then, so I've basically been able to do whatever I want. And one of the things I've spent a lot of time on recently is dealing with antidepressant withdrawal. This is hell. The last 2 months of my life have essentially been a write-off. I still haven't gotten over it. Like at BeerConf every night here, alcohol's like twice as effective for me at the moment. So. But, you know, you're all here to hear me talk about what I've been working on in D. So, you know, when I was at Remedy, I released that project Binderoo, and that was an open source project, right? Well, the good news is that thanks to that fact, I've still been working on it. I've mainly been working in my own little branch there. When it's stable enough, I will pull it back into mainline there. Now that we're getting into the presentation proper and not rambling about squirrels, I'll do the same little trick I did last year with this presentation. There's a little URL up there. I'm about to spam it to Discord and everything else on the planet. The idea here is that you click on this link and it opens up a little page that you can ask questions on, Twitter-length questions. Anybody can get on there and upvote their favorite questions. And the idea here is ask questions through that, because if you're familiar with my previous talks here, I tend to have a lot to get through. So this allows me to kind of schedule questions appropriately so that the talk doesn't go long. Okay, now that I've gotten that little bit of maintenance out of the way, let's go on and talk about what I've been doing with Binderoo. So, the first thing I want to talk about is C header parsing. This is something that came about because of a frustration that programmers had at Remedy. Having a function exposed to D essentially meant writing a duplicate definition of that function in a separate file to the C++ declaration. Now, this is exactly the kind of work that was required for binding a function to a scripting language, sure, but a point that I like making is that programmers are lazy by definition. I mean, it's literally our job to tell the computer what to do so that we don't have to do it manually. Thus being extra work here, it's a bit of a bad thing. And another one that happened a bit at Remedy, if your C++ APIs are unstable, this requires a bit of extra care to be taken. Every time your interface changes, for example, you need to publish a new build for everyone to download, and then you deploy update your D definitions there. And it wasn't a very automated process for Quantum Break. So clearly automation is the correct solution, though. But really, the main reason I started looking at this is because I wanted it for a project I'm working on. There's a library I want to bind, and it's like, well, sure, let's do it. So I had one goal in particular that I wanted to meet when determining a solution here, namely that it should work at compile time so that you can mix in a header if you so desired. And I've been doing a lot of compile time code. I didn't want to rely on templates here because they're a little bit slow for the compiler. There'd be a convenience mix-in template, but that'd be it. So a CTFE compatible function would be required. And that's easy to do. There's only one problem though. CTFE functions must be written in D and can't be called, you can't call a pre-built C pre-processing library, for example, during CTFE. So I'd need to write my own header parser from scratch. And this is in every way a bad idea, as I would soon discover. So I looked at just the basic idea, and I'm like, this seems fairly simple to begin. Scan for structs and classes, generate D structs that binary match them. Any functions that we find, make bind import declarations for them. Enums are pretty easy in C++. They're all integral types, so you can just duplicate them. And also we need to look for defines that declare constants and define them as enums. Simple, right? Yeah. Nah, I mean, I was just thinking we shouldn't even need to write a complete parser in Lexis since we're only looking for very specific things in the header. But no. So the reason I'm going to all this effort is because I want to use WX widgets. And there is an existing D binding for it that I could use, but since I'm going through Binderoo, and this would be hosted in my C++ host application, I essentially need to rebind WX widgets with Binderoo imports anyway. So rather than write separate test code, I'm just like, let's use WX widgets as a test space. So let's start off simple. Just use a defs.h up there, contains a bunch of enumerations and other things that are required. So it sounds like a perfect place to start there. And with that little mix in there, compile, and it'll take several minutes, okay? And then I look at Task Manager, and it takes over 10 gigabyte of RAM to compile. What the hell? That's kind of nuts. Of course, this being a little Binderoo thing, there's a very easy way to test a function running at compile time and running at runtime. That's to just apply bind export to it and invoke it with the Binderoo utility program. So I need more information than just running it, though. I want to know exactly why it's using this 10 gigabytes. And normally a classic game developer approach would be to write some kind of profile it, but I'll accept that we're in the future and there are tools for this. So let's have a look at what Valgrind talks about it. We run the massive tool on it, we open it in the visualizer, and turns out there is no problem. There's a peak of 450 kilobyte there, which is over 20 times more memory efficient than the same code running at compile time. Wow. So only now when I saw that I was thinking, yeah, see, header parsing, this is just sounding like a bad idea. Because of the CTFE memory usage and performance is kind of bad. And I've been told that this is mostly because of the way the CTFE engine handles strings here. But while I was working all this out, something else occurred to me. The include directive is essentially impossible to process at compile time. In simple cases, processing the headers one at a time and replacing the hash includes with D-module imports works. But C++ is rarely simple, especially since I was using WX widgets here. So common usages includes defines that change thanks to undefining them and redefining them. And especially important is that include order quite often matters. So each include essentially needs to be reprocessed every time you encounter it. So when you're in compile time, the import keyword is not nearly enough. And also, because I can run this function at runtime, It also requires standard I/O if you want to include files like that. And yes, I do hear that new CTFE will address all these problems, so the sooner that gets into main, the better. It also became clear to me around this time that my naive approach to doing header parsing like this ignored one very important fact. When you parse C++, it's actually parsing two languages. And I don't mean, that C and C++ are two different languages. I mean the preprocessor. Getting accurate results out of my parsing code was proving to be difficult since WX widgets relies heavily on preprocessor macros, both as a symbol replacement solution and more complicated mix-in style expansions. So this boils down to needing to write a preprocessor evaluation engine before you even think of scanning your files for functions and classes and enumerations and everything else you're interested in. Never, ever, ever look at the code for all this. It's a big Frankenstein's monster at the moment. Okay, so I am still working on getting all the niggles out, but it is getting there. Any include it runs across, gets added to an import list. It can understand type defs. It can generate aliases for them. That one's a function alias. Enums get translated with their correct underlying type, have the correct Binderoo attributes added to them. This little particular object that is getting bound here is generated with the WX declare list3 macro. And yeah, this knows just from that how to when to insert inheritance info and to preserve the order of the virtual function table. Still needs a little bit more work to bind up everything perfectly, but it's very definitely going to save my users a lot of time, especially in terms of automation. You integrate your header parser into your build process and publish the resulting files with your build. So that's great. Now we've got an automated binding solution for as much of your code base as you want. All right, so questions. Let's have a look at what we got here. Are koalas actually just rubbish squirrels? Have you guys heard of drop bears? They're a very, very close relative of the koala. If you meet a drop bear, you will not be thinking, this is not a rubbish squirrel. This is something I've got to run as fast as possible in the other direction from. Okay. So, what's this one? Why not just go super lazy and swig? And the answer to that is that it's an extra barrier of entry. The intention with Binderoo is to just cut down as much maintenance as possible, and keep natural language expressions there, and not need to invoke extra APIs whenever you want. And every little step that you have to include in this process gets away from that, and it represents a barrier of entry for anybody wanting to use it. Even needing to do the C header parsing separately, I'm not a fan of for that reason, but it's the only way that works right now. And there's also a comment here about this being cool. So, yep, sweet, I agree. All right, so let's continue on to the next. DI files. One thing I've wanted to do for a while is add DI files to the Binderoo chain, and there's a very good reason for that. Binderoo operates with a lot of template and CTFE code, and as I've just illustrated here, that's not the fastest way to do things. And since Binderoo is meant to be a rapid iteration library, precompiling all the Binderoo files, like all the core functionality and even your own bindings that are generated, compiling them into a library that gets published with your build seems like quite a sensible idea. There is a bit of a problem with DMD's DI generation, though. Mix-in templates don't get expanded. And mix-ins with a CTFE function like that also don't get expanded. And, Binderoo requires both of these things. So if you use one of the DI-generated files from the compiler, these all get re-executed and defeats the entire point of pre-compiling it to a library in the first place. Of course, Binderoo does a ton of reflection work. It actually knows everything it needs to generate these DI files itself. With every mix-in and CTFE function it cares about, we can expand them as well, since it operates on objects after the compiler has done all that work for us. So one artifact of doing this, when I try to generate it, I go through, parse the UDAs, and it just spits out the entire representation of the UDAs. Like a normal user would only define the test object there in the C type name UDA, but everything else that I hide behind the scenes gets expanded out. Oh yeah, I had a little highlight for that. But there you go. Importantly, they're preserved. And things that are normally hidden for you, such as the insertion of the virtual function table there, that's all expanded correctly as well as things like inheritance. Now, this is all done with mix-ins when you write code, but it all gets expanded correctly here, so that's pretty sweet. Some future work will be to expand the Binderoo service module to handle precompiled libraries and automatically provide the DI generation there, but for now, it's a little bit of a manual process. It's something I'm going to get to. Aha. Now, this is fun. Another thing that I've supported is multi-platform support. So, sorry. Console support is kind of locked away behind the scenes. Now, I don't actually have access to the Xbox One specific files anymore. They exist purely on Remedy's internal servers. But there are other platforms that I can support here that everyone would actually find useful. Because let's face it, hands up who develops on the Xbox One here. I expect like a couple of other hands. Yep, exactly, that's it. So anyway, Binderoo now works on Linux. Hey, I'm actually presenting on Linux here, installed on a USB stick, just to prove this point later on. Switching between Windows and Linux to ensure that I keep multi-platform compatibility up is simple because Windows is installed on my hard drive. Fairly important as well is that Binderoo now also compiles with LDC and Clang. Hey! I compile exclusively with LDC and Clang on Linux and switch to DMD in the MS Visual Studio toolchain on Windows. But either way, with LDC and Clang here, that is a clear path forward for supporting PS4 and OS X. I don't imagine OS X will be hard at all from this point. I just don't have the hardware to develop on. Forward. There we go. Now, porting to Linux, that's actually quite easy. I've been a multi-platform engineer my entire professional career, so writing Binderoo originally in a manner that was conducive to cross-platform operations is just something I do. It comes naturally. And it really just came down to replacing the Windows API calls with POSIX calls in the right locations. The main ones there were dynamic library handling. DLOpen, DLClose, DLSim served me well. One little niggle I came across, though, was that Linux doesn't have the Windows DLL attached messages. I know, right? Because they're not DLLs. But that's how the D runtime initializes on Windows when a DLL is loaded. Now, important to remember here is that the Binderoo host is a C++ library that handles dynamic loading of libraries. In this current case, we write them all in D. So the D runtime is never initialized anywhere to begin with. It's not linked anywhere else. This is a reasonably easy fix. I just do what I do in Windows. And I've standardized it with the Binderoo startup function. And this actually ended up reintroducing a quantum break problem that I never properly solved back then. So in a heavily threaded environment, the other threads in your process, they'll call the D runtime thread attach code via the thread attach message before even the D runtime is finished initializing. And this leads to the program crashes you would expect. And you know, Linux doesn't have this program. You load the library, and now it's just code in memory, and whatever you do from there is entirely up to you. But now that I've had at least 5 minutes to think about it, the solution was simple enough. Just use a good old critical section in Windows and mutex lock the thread and detach routines behind it. Why not one of the D runtime builds in mutexes? Wow. They're built-in mutexes, that's what that's meant to say. Anyway, why am I not using a built-in mutex? And that's pretty simple. Being a class and not a struct means that it needs to be allocated before usage, which requires the garbage collector, which gets initialized in the D runtime. So if you try to lock that in your DLL thread attach, nope, it's going to access a null pointer, so good luck with that. So the critical section, though, being a Windows API value type, it doesn't require allocation, and it can live on the stack. So that's pretty easy. I just put that in there. One other thing to note, though, is that we do, in fact, introduce a mutex lock on every thread attach. which means if you have a ton of threads in your code, you're going to notice a clear pause whenever Binderoo does rapid iteration and reloads your code. On the other hand, rapid iteration is designed to be a development tool and not for retail code. And if you initialize your Binderoo program fairly early on when you only have your main thread, the hang will just be non-existent in your final retail code base. There is one very big thing I definitely need to solve here, though. Each Binderoo library still embeds its own copy of the D runtime. And this has always been the case on Windows since the D runtime hasn't been able to live in its own DLL so far. But I am copying this pattern on Linux to get things up and running. Linux does have the D runtime available as a shared object. That works for most use cases. That's kind of the architecture. You link your program to, say, load up the D runtime shared object, and it's just code that already existed on the system, and all the runtime initializations are made as expected. But Binderoo is not a normal use case. We need to load our libraries dynamically, which means modules, module info and all that needs to be initialized per library. And then with rapid iteration, we need to undo that and then unload the code and then reload in the new code and re-go through the module initialization routines again. Now, of course, if you use Better C, that's not a problem. But my original users, when I started writing Binderoo, they don't want a Better C. They want a Better C sharp, effectively. So using Better C in everything that it implies, not really an option here. It's question time again. Look, Finland's fiction, how about that? Here we go, Stefan. My version of first-class type will fix the template problem. Reflection will be super fast. Put it in main, now, go. No? Okay. All right. That's the only extra question I have here right now. So let's just continue. Forward. And now, there has been one feature requested for Binderoo. It was never, ever, ever, ever planned. So, thanks to the power of open source and me being on my own time, Binderoo now has .NET support. And this greatly increases the number of applications that can use Binderoo in the real world, so this is absolutely a good thing. There's now a little Binderoo host.NET subsection of the Binderoo host component. It is a bit divergent from the original plan of compiling Binderoo hosts with C++ CLI. And that was actually pretty easy. The way I wrote the code to begin with, there's not a lot there that C++ CLI hated. But then I came across a stumbling block. C++ CLI is not supported by the main .NET compilers, and is instead a component of the Microsoft Visual C toolchain. These are Win32 and Win64 applications that you need to run on Windows or a Windows VM or whatever. You know, you can run it through Wine, you can do whatever, but that's a bunch of work that shouldn't be necessary. So scratch that. Instead, what I've got there right now is a minimal C API that wraps up Binderoo host functionality, and the .NET assembly, Binderoo host.NET, just wraps around that. I really don't recommend using this API yourself, though. It exists solely to make my life easier when supporting .NET here, and it is prone to change without warning. So don't think, hey, I'll just D++ it and link it. No, don't do that. So getting Binderoo running in a .NET environment wasn't that much of a problem taking this approach. Then it came time to writing example code to show how it works. And I came across a bit of a long-standing annoyance. If I wanted to export any function to C++ with Binderoo, I'd need to go up there and declare it as extern C. And this would also lead to entire objects being declared as extern C, just to ensure that the functions would default to C++ calling conventions. And it's really just an annoying bit of work that doesn't need doing. And there's also some very serious problems with doing it this way. See, up here, you got a function, named SumFunction, in test1 module there. And in the test2 module, you have a function called SumFunction with the exact same signature. And this gives you a compile error. And there's a very good reason for that. Thanks to C and C++ mangling rules, these two functions generate exactly the same mangled string. So it's a duplicate definition problem, essentially. Now, you can get around it by declaring a namespace in your extern C declaration, but again, that's extra work. And we can absolutely do better with Binderoo. We can ditch the requirement for declaring the function as extern C++ entirely, in fact. Binderoo already does a bunch of compile time code generation, so what's a little bit more, right? Whenever we find a function with the bind export tag, now we just go through and generate an anonymous wrapper function for it and export a function pointer to that function instead of the original function. Any code calling that function from D code uses the native calling convention because it's not aware of the wrapper. And from the code outside, the function pointer points there and calls the D code. And nobody's any wiser about it. It's kind of funny, though. It does make for a bit of a funky chain to explain for .NET interoperation, since you have to marshal your parameters to the native format, marshal the function pointer, invoke a C++ function, which then rewrites the parameters into the D ABI format to call a D function, which executes and returns a value in the D ABI format, which the C++ wrapper then returns in the C ABI format, which finally gets unmarshaled, etc., so that you can use it in .NET. There's not really a good solution for that, short of the .NET runtime and C compilers supporting decalling conventions. So not much to be done for that little chain, but hey, it works. And just when it looked great and it was all running, I compiled with LDC and hit an LLVM-specific problem. Every function symbol is generated and exported, including my anonymous functions. Even better, if you have a C++ function inside a template that's a D template that uses a D string parameter, that's just right out of the question. You immediately get a compiler error saying C++ types can't be templated with strings, or any D-specific type, really. So, you know what I did here? Anyone? No one? Okay, I cheated. I used pragma mangle. I just generate a new mangle for it and be done with it. There's no hope of ever resolving this symbol automatically through the normal symbol resolution schemes, but I don't care. It's meant to be an anonymous function. And now there's no symbol clash. LLVM can continue doing its LLVM things, and our code will just continue to work. Okay, so we export our functions just fine now. Now we need to import them into .NET. Knowing that C# uses the concepts of generics, similar to how templates work, I decided to be, a nice, responsible modern programmer. I started off creating an imported function generic object. Now, it turns out that C# generics really aren't that powerful. So to support multiple parameters with your function, you got to do it the old school C++ style. Define each permutation you want manually. All right, this only needs doing once. It shouldn't be that much of a problem. So, this looks like fairly simple code here. Nothing too tricky. Our function pointer will get our function pointer gets retrieved from Binderoo, and it gets stored in this little FP value on construction whenever it gets reloaded. Cool. Compile it, and it works fine. Run it though? No. See, the .NET runtime will throw an exception on this line, and the reason here is that it turns out that the type of parameter for getDelegate for function pointer does not accept generic types. DT here being a delegate definition inside a generic object means that it is a generic type. And I really have no idea what the reason for this is. It's an utterly stupid restriction from a user point of view, and it meant that I couldn't do it like that. It's also something else fairly annoying, generics. See, when you would call a native function, you can use the marshal as attribute to automatically convert a .NET managed type into a native object. Up here we've got the string, for example, that gets converted into a string pointer. Convenient, except it doesn't work like that at all. It can only be applied directly to those function definitions and delegate types. You can't add attributes to generic parameters. So even if the getDelegate for function pointer function were fixed to accept generic types, being unable to apply attributes easily there means that you manually need to convert your C# types to D. And that makes it essentially unusable in my opinion. I really want to have a long talk with whoever created C# generics. So there's nothing for it. Delete that work. The compiler will never see it again, and it can be happy. But we still need a solution somehow. And this is where Binderoo's native functionality points toward a solution. See, I mentioned the Binderoo util thing earlier, and you can already load up any Binderoo DLL and ask it to generate C++ code that when you include it in your host programs build, automatically exports all the function pointers required to Binderoo. And it's really not much of a leap from there to get Binderoo to generate C# code that does the reverse, importing functions from a Binderoo DLL. And this is really something that the C# compiler should handle for me by letting me use generics properly. On the other hand, though, it highlights a very cool paradigm that Binderoo is kind of stumbling headfirst into. All right, so if you were to write a library, release it onto the internet, you'd release your binaries, or if you're an open source project, you'd release the prepackaged binaries and the source code together. And generally, you'd also want to ship a C or C++ interface with your library. That's kind of important if you expect people to be able to use it, and especially if it's a binary-only release. Documentation. Documentation is also pretty important. So you've packaged all that up, you've released it, you congratulate yourself on a job well done. But that's not where things end. See, because if your library is useful, someone on the internet will make a C# wrapper for it. Maybe also a Python wrapper. And hey, why not a Java wrapper while we're at it? And then they won't ever be maintained by the person. So other people on the internet will make another set of wrappers. And then you'll need to investigate and choose between them. And before you know it, the internet has created wrapper hell for your library. Just look into OpenGL sometime if you want to get an example of how bad this can get. Now, the Binderoo library, however, has a key difference. It essentially starts off in the same way. You upload your binaries and your source code. But without doing anything special here, you can automatically get a D interface and a C# interface. And you know, if I spent just a little bit of programming effort, I'd even be able to generate a C++ interface. And this is essentially achieved by asking it nicely. You load up your Binderoo library with your Binderoo util, and you can get all the information you need out of it. And this is essentially the same approach that .NET assemblies take. So it doesn't matter what .NET language you use to author an assembly. Every language that .NET support knows how to use it without needing, wrapper libraries. And that's pretty cool and far more preferable to the old way, in my opinion. All right, so here we are. We're in C#. Yep. To preserve our D module names, I put everything into namespaces. And here's the thing. We've already encountered our first problem. So you can't declare static variables inside a namespace or static functions. That's not how C# works at all. So we're going to have to do something really nasty, even though C# tells us this is actually the correct way to do it. Did that go forward? No, it didn't. Forward. There we go. We're going to use public static classes everywhere, basically, instead of namespaces. This allows us to preserve D module names and avoid symbol conflict. And I'll get to why this is nasty in a second. There is a whole bunch of stuff hidden down the bottom of a generated code file within a hash region block, but I've just left it all there to display how it works. So the imported function object has survived, but it's no longer a generic object. Rather, it's just a .NET object that wraps up those C API functions that I wrote. So it's fairly useless by itself, and it absolutely needs all the generated code support to work. But as far as anybody programming in C# needs to know at the end of the day, they can write their code naturally, and everything just works. Although, when I say naturally, that is a bit of a lie. Because everything needs to be in public static classes to work, you can't declare using declarations to cut down on the amount of code you need to write. So you need to fully qualify your D functions every time you call it. That's really not ideal as I see it. But hey, it works. Kind of sick of saying, hey, it works. I just want it to work right. Now, calling functions in D is great, but we need more. Because as a game developer, you really don't get far without aggregate types. So we need to export compatible aggregate types to C# that can work interchangeably with D. C# can already match the C ABI definition of a struct, so that's cool. Value types, they just match, in D, they match the C ABI, so that's easy. We can generate a C# duplicate, and that's great. What about classes? Classes are a fair bit more involved. So last year when I presented my talk here, I had a little slide there on value and reference types. It went to my rationale for binding all C++ objects with D structs. The ABI is matched there, but a D struct has its own custom ABI. The C# doesn't know, C# or even C++ doesn't know about. The reason I'm bringing this up is that C# also has a reference type, and it's also called class. So this is where things get really tricky though. So while Microsoft has been officially open sourcing .NET, and there's mono and all that, the ABI for a C# class is technically unpublished. And that's really advantageous for Microsoft. By not publishing it and telling programmers that they don't need to know about it, it means that they can change the ABI behind the scenes. And they have done this. The most recent change has been in the CLR 4.0 version. It introduced a new class layout, and a bunch of people had to rewrite their code as a result. Now, Binderoo operates on an allocate once, use anywhere principle. Interoperation just works seamlessly because each object operates just as well, regardless of which language you allocated it in. But wrapping a D class as a struct means treating a D class as a value type, and that's full of its own set of problems. And since we can't trust the binary layout of C# objects, attempting to recreate that object in C# and allocating there will also absolutely violate the allocate once, use anywhere principle. It turns out, I did actually have a cunning plan after all there. Just hide everything. Rather than trying to copy the binary layout, we just make a deallocate it. Allocate your some test class in C#, and it'll make the appropriate Binderoo calls to create an object through the C++ API and store it in the import object. And whenever the object needs to be passed to a function, since we generate this code all the time anyway, we can just simply retrieve the pointer and forward it along. And nothing's any wiser as to what's going on, and it just works. C# users are now free to use objects written entirely in D. It's pretty cool. And just to prove all this, I have the least impressive live demo of all time to show. Switch over here. Where did that go? Yep, excellent. So this is just a little class I've written called dCalculator. And this is D code. I can just, if we switch over there, there's the generated C# code from Binderoo. And just to show that that works, I can write void hello DConf. Hey! We got a function there. We can save that. We can come out and compile it. No, that's the wrong one. And if we come over here, this will refresh in a second. Any second. Now there it goes. We've now got new generated C# code there. And then you can go one step further. I'm in Linux here, so I've got monodevelop open, build and run. There it is. It's popped up on this screen. Great. Look at that. That is a .NET window written in Windows forms, and all the logic for the buttons here is just entirely contained in the D code. And it's not really impressive. I mean, what's the second program everybody writes? It's after Hello World. Everybody's like, hey, now here's how you make a calculator. So this isn't impressive at all. It just shows off that everything works. Alrighty, so I'm getting towards the end of my talk here. In fact, that's what that slide tells me. It's almost the end of the talk. Upgrading Binderoo. It's been just one of the things I've been spending time on. Some of these modifications I've talked about actually have been the result of a consultancy. So I guess I can put D-consultant on my resume now. But I've also been spending a bit of time on something else that's fairly significant. See, I quit Remedy because it was time for me to get out and do my own thing. And I've been putting together a pitch to get investment for a company which will write the kind of tech I need to make the kind of games I've want. And yes, I have actually already started writing that tech in D. And that's all I can really say about it for now, but that there will be the logo, and that's its first public appearance. Doesn't it look nice? Yeah. It's not a squirrel. Again, because Australia is a fictional place, so this is one of Australia's fictional animals. But yeah, when I'm in a position to tell you all some more, well, I will make an announcement about it. And now it's final questions times. And there's actually no extra questions through Google Slides. We've got 12 minutes left, so let's... oh, wait a minute. Is it a kookaburra? Yes, it's a kookaburra. Okay, so if anybody wants to ask questions through the microphone, now's the time. Up the back there.
Yeah, we've got plenty of time for questions, so don't be shy.
Yeah, I ended up cutting a few slides out because I thought I may not have the time for it. But
You told you've been annoyed that you need to fully qualify the functions in C# if you generate them. Have you considered using extension methods in C#? Like labeling the first parameter with this so you can call them with universal function call syntax?
Honestly, I've not looked into extension methods. Yeah, I mean, my C# usage is reasonably superficial to a proper C# programmer. So by all means, I'll look into that and see if I can improve it. As soon as I can get it so that you don't need to fully qualify it, I'll be happy. Anyone else? We do have crickets in Australia. They go. Yeah. All right. Well, I guess if there's. Oh, wait a minute. There's a question here. Where do I apply? I assume this is in relation to my company that I'm starting up, and well, it's not actually a company yet, so you can't apply. Needless to say, when I do make that announcement, then maybe there'll be job postings.
So I have a question. What was your experience using the iDisposable?
I'm sorry, I can't hear.
What was your experience using the iDisposable interface in C# related to these destructors?
Okay, I'm having trouble with the accent there. Sorry, I'll walk up and. I'll be able to hear it better, not over the microphone there.
So I noticed that you're using iDisposable in C#. So how this play with these destructors?
Well, at the moment, it kind of does all that after you hit program close, and it causes a cert in the C++ code. So it's something I've still got to work on. But, you know, you can use the program just fine, just never close it. Anyone else?
Okay, no more Google questions?
Yeah, sorry? No, there's nothing else here. I guess we're done.
All right, thank you very much, Ethan.